Weekly artificial intelligence and robot news. What are the most jaw-dropping inventions of science after the internet? The answer is, undoubtedly, artificial intelligence and robotics. The AI and robotics system has progressed so much that we can create a new Adam and Eve and write a new history. Through each weekly update, we share with you a small stepping stone to that advancement. Let's see, what do we have this week? Hello everyone! Welcome to my channel. Don't forget to subscribe and like, and also press the bell icon to never miss an update about artificial intelligence, robotics, and future technology. That being said, let's begin. This is where we'd start. Hand motions are recognized by the system. Researchers are working on a new technology that allows users to control computers via hand gestures. TypeIke is a prototype that uses an ordinary laptop webcam with a basic effects mirror. The application detects the user's hands near or alongside the keyboard and suggests operations based on their location. For example, if a user places their right hand near the keyboard with their thumb pointing up, the application will recognize this as a signal to increase the volume. A variety of gestures and combinations of gestures may be programmed to do a variety of tasks. Human-computer interface (HCI) innovation strives to improve user experiences quicker and smoother, with less reliance on keyboard shortcuts or mouse and trackpad operations. Next, to combat invasive fish, robots utilize fear. Gambusia holbrooki, an invasive mosquito fish, displays the tail of freshwater fish and tadpoles, allowing native creatures to perish while feasting on the eggs of other fish and amphibians. Researchers created a robot to frighten away these mosquito fishes, demonstrating how fear affects their behavior, physiology, and fertility, as well as how it may help reverse the tide against invading species. To combat the invasive fish, a multinational team of scientists and engineers from Australia, the United States, and Italy looked to the largemouth bass Microprotus salamoides, the fish's natural predator. They created a robotic fish that looks like a genuine predator and moves like one. Using computer vision, the robot attacks when it sees mosquito fish approaching tadpoles of an Australian species that are endangered by mosquito fish in the wild. When scared or agitated, mosquito fish exhibit fearful behaviors, lose weight, modify their body shape, and have lower fertility. All of this makes it difficult for them to survive and reproduce, according to lead author Giovanni Polverino of the University of Western Australia. Mosquito fish is one of the 100 most invasive species in the world, and present ways to remove it are too expensive and time-consuming to successfully counter at speed. Many aquatic creatures are threatened by this worldwide scourge. Rather than eliminating them one by one, we're providing a strategy that can help better control this global scourge. We brought their greatest nightmare to life, a robot that terrifies mosquito fish, but not other creatures in its vicinity. Next, bringing discovery closer to its use in AI networks. Researchers have successfully proven proof of concept in artificial neural networks that resemble the human brain using their multimodal transistor, or MMT. This is a significant step toward employing thin-film transistors as artificial intelligence hardware, and it advances edge computing by decreasing power consumption and increasing efficiency rather than depending entirely on computer processors. The MMT, which was initially announced in 2020 by Surrey researchers, overcomes long-standing transistor difficulties and can execute the same tasks as more sophisticated circuits. This study, which was published in the peer-reviewed journal Scientific Reports, employs mathematical modeling to demonstrate the notion of employing MMTs in artificial intelligence systems, which is an important step toward manufacturing. The researchers demonstrated that well-designed multimodal transistors could operate reliably as rectified linear unit type, or ALU, activations in artificial neural networks, achieving nearly identical classification accuracy as pure or elite implementations, using measured and simulated transistor data. They train an artificial neural network to recognize handwritten digits using both measured and simulated data, as well as empty data, and compare the results to the software's built-in feature. The findings support MMT devices' use in the thin film decision and classification circuits. In more complicated AI systems, the same method may be employed. Next, there will be AI security devices at CES 2022. At this year's CES, the world's largest tech show, MicroAI, a Texas-based Edge AI product developer, showed its Launchpad Quick Start deployment tool with this new security software. This year's CES was held in the Las Vegas Convention Center, LVCC, from January 5th to 7th. At Exhibit 12318, MicroAI has teamed up with communication solution provider Ibasys to demonstrate Launchpad management capabilities. The demo will demonstrate how Launchpad controls micro AI applications running on embedded devices and handles data from many sensors using iBasis connection. It will also demonstrate the Launchpad's ability to securely manage a fleet of SIM cards from a single platform, making mobile device maintenance easier for consumers. Edge native AI enables embedded AI software to operate on microcontrollers and microprocessors in endpoint devices, revolutionizing how AI can be made available directly where data is gathered, stated Micro AI CEO Yasir Khan. Launchpad makes it simple for businesses to handle this, bringing up new options in a variety of industries. Next, Nokia is the next company to implement AI video. Nokia today announced that Baseland Transport, AGBLT, in Münchenstein, Switzerland, has deployed its Scene Analytics product. To maintain the safety of train crossings, the AI-based system uses computer vision and machine learning technologies for real-time monitoring and analysis. Nokia's work and Schweizer Electronics and BLT, which was the first of its type in Europe, established the viability of AI-based train safety solutions in everyday usage. Because of the risk of serious injury or death at level crossings, rail officials are concerned about the safety of passengers and cars. According to statistics from the European Union, level crossings caused roughly 250 deaths and 300 serious injuries in the EU 28 nations in 2018. Even the finest warning systems may be circumvented, and crossings can be obstructed. Thus, train operators need to be notified of problems in real time. BLT may employ machine learning techniques based on CCTV footage to determine what is normal and what is abnormal by integrating Nokia Scene Analytics. The AI-based technology not only reports abnormalities to railway security in real time, but it also recognizes the object kind, giving a more full view of the issue. The storage of event-based video clips, pictures, and related data allows for post-incident forensic investigation. Scene Analytics on railroad crossings improves operational savings by reducing downtime and delays, in addition to enhancing safety and reaction time. Its machine learning capabilities decrease the amount of time that rail staff must devote to manually updating the system. As a result, Nokia Scene Analytics allows railway operators to save money in the long run. It may also be used with a variety of industry-standard cameras, lowering the total cost of ownership and enhancing return on investment. The safety of passengers, pedestrians, railway operators, and automobiles is notoriously challenging at level crossings. Nokia Scene Analytics functions as an intelligent set of eyes, preventing or mitigating the effect of an occurrence by giving important information in real time. The first deployment of its sort in Europe, this initiative with Schweizer Electronics and BLT will allow rail operators to close barriers and respond to critical circumstances at crossings in real time. Next, there's a new AI navigation system that presents SpaceRex. What do you call a satellite that has malfunctioned? It's now a multi-million-dollar piece of hazardous space debris. Engineers are getting closer to developing robots that can repair broken satellites or spacecraft in orbit thanks to a new collision avoidance system developed by students at the University of Cincinnati. Daegyeon Choi and Anirudh Chabra, doctorate students in the UC College of Engineering and Applied Science, presented their thesis at the Science and Technology Forum and Exposition in San Diego in January. It's the world's biggest aeronautical engineering conference, hosted by the American Institute of Aeronautics and Astronautics. For autonomous systems to accomplish a task safely, we need to develop a reliable collision avoidance algorithm that runs in real time. As a result, we suggested a new collision avoidance system based on explainable AI, Choi stated. The UC researchers put their system through its paces in simulations, starting with robot deployment in a two-dimensional arena. What is their preferred digital battleground? Multiple autonomous robots must safely walk aisles to assist customers and staff in a virtual supermarket. If an autonomous robot unexpectedly collides with a satellite it is trying to repair, the robot, the satellite, or both might spin out of control. For drones or flying automobiles, the collision avoidance technology works just as effectively in 3 dimensions, according to Bryce Tech, an industry analytics group. Satellites account for around 1/3 of the $371 billion global space economy. The UC system uses explainable AI, which is a sort of artificial intelligence. It employs fuzzy logic, which is a system based on degrees of truth rather than a binary right or wrong. Next, there's a novel brain-computer interface with a pliable foundation. An improved brain-computer interface with a flexible and moldable backing and penetrating microneedles has been developed by engineers. The addition of a flexible base to this type of brain-computer interface allows it to adapt more evenly to the brain's complicated curving surface and distribute the microneedles that penetrate the cortex more consistently. The microneedles emerge from the flexible backing, penetrate the surface of the brain tissue without penetrating surface venules, and record impulses from neighboring nerve cells equally throughout a large region of the cortex. Rodents have been used to test this innovative brain-computer interface. The findings were published in the journal Advanced Functional Materials on February 25th. This research is being led by a team from the University of California, San Diego's electrical engineering professor, Shadi Daye's group, as well as researchers from Boston University led by biomedical engineering professor Anna Dever. The Utah array, the present gold standard for brain-computer interfaces, using penetrating microneedles, is on par with and exceeds this new brain-computer interface. The Utah array has been shown to aid stroke sufferers and persons who have suffered spinal cord damage. People who have Utah arrays implanted can use their thoughts to operate robotic limbs and other devices, restoring some basic functions like manipulating items. The new brain-computer interface's backing is flexible, conformable, and programmable, whereas the Utah array's backing is rigid and inflexible. The innovative microneedle flexible array and conformable backing promote closer contact between the brain and the electrodes, allowing for the better and more uniform recording of brain activity signals. The researchers used rats as model animals and exhibited sustained wideband recordings that produced strong signals for the life of the 196-day implant. Furthermore, the way soft-backed brain-computer interfaces are made allows for bigger sensor surfaces, allowing for simultaneous monitoring of a much wider region of the brain surface. The researchers show in their publication in Advanced Functional Materials that a penetrating microneedle array with 1024 microneedles